Welcome everyone to our virtual tour. I am Pat Tierney, CEO of Revolution Systems, talking to you from Golden, Colorado, elevation somewhere around 6,500. And virtually, I'm here on the highway, Highway 9 from down in Dillon up to Steamboat Springs. We've just passed over Rabbit Ears Pass, and we're on our way down the mountain into the Route Valley, the Yampa Valley, over to Steamboat Springs. And I want to welcome you to this virtual tour. We've always had trouble getting planes, trains, and automobiles to get people to our test facility in Steamboat Springs. But thanks to modern technology and a little motivation from COVID, we're able to bring this to you somewhat live, and we're able to do some things that you can't ordinarily do on a standard tour. For one thing, we're missing out on all the planes, trains, automobiles, 2 mountain passes, tunnel traffic, the tunnel, and all the weather. The weather here is always nice, as you can see. It's a beautiful spring day. And all we've got to do is snap our fingers, and voila, we're here in Steamboat Springs, a community of roughly 20,000 people, give or take a few skiers or more, or a few anglers as it is in the summer. Right now, obviously, we're here at the height of the summer season, and so the population's a little bit high. One of the things about Steamboat Springs is its size. Ordinarily, Steamboat Springs, just like us, would have to send all of its recycling to Denver, which would involve the mountain passes, the 2.5 to 3 hour drive, except when there's an accident on Highway 70, trouble with the tunnel, as well as trying to figure out what road is closed, depending upon skiing or fires or what have you. So at any rate, real quick, we're going to snap our fingers again. We're going to head about 10 miles to the west, and while we're doing this, we're going to talk a little bit about what happens in Steamboat Springs. So ordinarily, your recycling trucks pick up recycling at your house and other homes. We're all used to this if we live on the Front Range or in a bigger town. That truck carries about 7 tons. It goes to a transfer station, as it did in Steamboat Springs up until the end of June in 2016. That transfer truck, 14-ton load, would have to head down to Denver, planes, trains, and automobiles, about 150 miles, to have its recycling sorted and sent on to market. That 14-ton load would have to go back empty to pick up another, which means effectively our efficiency on freight was about 7 tons a load. Not much to be proud of. Where by contrast, once we have baled material, it's a 21-ton capacity. So now that we're finished with our short drive, let's take a look at the facility. Here we are in Milner, Colorado, just a little bit to the west, about halfway between Steamboat Springs and the airport, the Hayden Valley Airport, and about 6,500 square foot building. And as you can see, our SUV is arriving here over in the left. Before we get started, I'll just let you know, no worry about PPE, no worry about boots or anything like that, no need for glasses. But we do want to try and give you a quick overview, which is something we can't typically do on a tour. So here we are, 6,500 foot bird's eye view. We're going to start with tipping. We'll talk a little bit about tipping and tip floor management. Then we'll work into talking a little bit about sorting. We'll talk about some of the advantages of a circular sorting system. We'll go into the storage and storage facility, some things about considerations for storage, and then we'll talk a little bit longer about shipping before we wrap and go into questions and answers. Try to get this done in 20 minutes. One of the nice things about the tour, once again, is when a truck arrives, you don't have to wait for it. There are always trucks arriving. In Steamboat, typically it's about 4 trucks a day, not too many that arrive. We have 1 or 2 that show up in the morning, and then a bunch that show up in the afternoon. Afternoon shift is really what drives the size of our tip floor. Let's take a look, and let's walk onto the tip floor now and take a look and watch as we start to tip and dump. As you can see here, we've got about 3,000 square feet available for tipping. this it can quickly get filled up by 2 or 3 trucks. And as you can see here, we've got enough ceiling height for the truck to go ahead and tip. A lot of cardboard in here. Post-COVID world, we're looking at lots and lots of cardboard. A lot of people who are heading down to the Front Range to pick up things in Steamboat or heading to Grand Junction, as it were, are now starting to get more and more stuff from Amazon. So we have a lot more cardboard. A lot of the larger cardboard we're able to pull off here on the tip floor, and we're able to send over to the baler, which is right over here to my side. But for now, let's do another thing real quick. Let's step back in time to July 3rd of 2016, just before the system started up. Oh, hang on a minute. We've got a little problem. We forgot to report our incoming material. As we can see here, Simple Insight is a tool developed by Revolution Systems to help MRF management. We're going to go ahead and enter in the incoming material so we can bill for it and keep track of our efficiency and other important metrics for the product. So here we are, July 3rd, 2016. Everything's nice and clean, everything's nice and new, and everything is accessible. You can see here on our feed conveyor, we've got these cleats here that are helping to measure the material. It's very important that the material be evenly measured and spread out for the material, for the people who are up top sorting. You want them to see a consistent picture so that they can be as diligent and as accurate as necessary. One other thing you'll see as it comes up, so this grabs some material, but sometimes it grabs a little too much. So you see that blue piece right up at the top, that's a metering wheel that kicks off the top and makes sure that we don't have too much material, too chunky, coming in over the end. And so we have gravity that starts here with pushing things onto the tip floor, imparting very little material energy onto the material so that it doesn't get contaminated, doesn't break, doesn't jostle, and then it heads on its way up. Gravity works to try to help meter it out, and then just to make sure we're going to tip it, knock the top off with the metering wheel. Having a metering wheel up top is an innovation here. It's one of the things you do when you don't have a huge MRF. You try to make do, and you try to make things work in your favor, use nature as much as possible, and that's one of the things we're doing here. So let's go ahead and take a look. We'll watch our operator. He's going to push some material on. He's already starting to meter. He's getting one bucket. He's laying the bucket out and pushing it onto the feed conveyor as it heads on its way. Now we'll take a look. We'll watch some of those cleats at work, and we'll watch how gravity helps to make sure we don't have too much material before it heads on up to the metering wheel and gets knocked off. So real quick check, we've just took a look at the feed conveyor. We talked about the importance of getting a nice even feed, and now we're going to take a walk up the stairs. Before we do, let's take a quick another bird's eye view to get our bearings, something that we need to do when we're in this virtual world to know where we are. So here we are looking down. You can see the feed conveyor coming down out of the upper left-hand corner. Material comes in, drops onto the table. We take off the OCC, the big stuff first. Then go for the mixed paper. Taking the mixed paper off next helps to uncover everything that's underneath, so we can get to work on the HDPE, the plastics, get things ready for the magnet, which is right over here, and then get to work on the aluminum cans listed as UBCs there, the glass bottles, before everything is knocked off via our brush. The brush is right there above my finger there. You can see that crossing the table. That pushes the material off, and the waste and residue heads off to the top. Pretty much right back the way it came. It goes on to another conveyor, which then takes it immediately out of the building. One of the things I'll have everybody note is we don't spend any time in this system with residue. The residue isn't touched. It comes over the belt. If we can get it out earlier, we would, but it comes out over the belt, nobody touches it, and then heads on its way. Let's take a walk up the stairs and see where the action is. I feel like Rick Moranis during this part of the tour. Here we go. Now I'm the right size. Here we are. As as we were talking before, here we have on this side, we've got the OCC, the cardboard, and the mixed paper coming off. Immediately behind me is where we start to sort the plastics. Over on this side, we have our magnet that's taking off our metals and then we have our UBC, our aluminum cans, and our glass before hitting the magnet or the brush, which is right over here. See if I can get to it. There we go. Get to the brush and send it on its way to the landfill. Immediately behind me is a control panel. This control panel is where we can control our feed rate from our feed conveyor. We can control the table speed. We can control and adjust the magnet and the brush and so on. But let's watch everybody in action. I want you to note we don't have as many people as we do stations, but everyone has the ability to sort every material. You can see the operators are able to work together. In some cases, one operator per station. In other cases, multiple operators per station. This operator is operating at 3 stations at once. Here we see we have a full complement. All total, we have 10 total stations on the Revolution. They can be operated by as few as 1 person or as many as 10 people. Now we're getting a little loaded here. A lot of material out on the table. A lot of that's going to get pulled off, or some of it's going to get pulled off by the magnet. Here we go. Don't try this at home. Let's see the can get picked up and dropped off. Now we'll get a little bird's eye view. No, we've got a bottle and an aluminum can, but there's that peaches can, the tin can gets taken off. Now, note we've got a really heavy load here, and Wilmer's having a hard time catching up. So it looks like we're starting to send some stuff over into the landfill that we don't need to. So we're going to go ahead and we're going to raise up the brush. We're going to slow down the table. This is something that we train our operators to do in terms of technique. We try to get them so that everything's in balance and we're able to brush the material off. But you know, sometimes new truck, new material mix coming from a different neighborhood or so on, and it gets difficult to keep up. So we go ahead, we adjust the brush, we adjust the table speed, and the team's able to keep up with the load. This is really important because as much as your waste characterization study can tell you, you know, what you have in your load, it's wrong, and it's wrong from minute to minute. It's wrong from season to season and week to week. And it's wrong from neighborhood to neighborhood. So, you know, for example, in Steamboat Springs, if you're driving through Main Street where all the bars and restaurants are, you're going to get a lot of cans and bottles, you know, maybe not as many boxes, and maybe it's not as much mixed paper in the load. By contrast, you go to one of the residential areas, you're going to see something that's a little bit more balanced as you go. So real quick, let's recap what we could see here. You have the ability on a Revolution to have 1 person handle multiple materials. People can work together as a team when someone gets overloaded. By contrast, the fixed stations on a standard linear system make it a little bit hard to maintain that operating tempo and that utilization. And so you have a poor guy there who's waiting for his can to arrive. And while he's waiting, there's not a whole lot he can do to contribute to the team. By contrast, we get about 37% more efficiency from our teams. They're able to work a lot faster. They're able to talk while they work. It's a much more social environment. And they're also able to rotate through stations. Next stage is baling. We can feed bins, we can feed balers directly. We try to feed balers directly when the ROI will necessitate it, but sometimes we don't, and we have to use bins. Here we're loading some bins of mixed paper into the horizontal baler, and that horizontal baler is going to go ahead and feed from there. Similarly with Autotie, a lot of people will go with one single Autotie baler, and that will have everything feed into it. We find that that is not as good as getting a baler under every station. It actually makes more sense to go ahead and do the manual tie, but to eliminate having to move things around. The less movement we have and the less of the material, the better off we are. Let's keep moving here, Sagar. We're running. We got to get everybody out of here in 30 minutes, and I think we're falling a little behind. I'm going to get out of the way real quickly here because this lift truck is going to need to take this material. And we're next going to weigh the material on a scale. We sell material by the truckload, but we do track our bale weights. It's important to make sure our machines are running well and that we're loading the material properly into the baler. The scale is immediately into where the camera is. I'm going to go ahead and push that on. And if you see, we have the scale reading window is right at about eye level for the operator so that he can see as he's pulling off what the material size is. And then go ahead and report that through Simple Insight, report our production, so that we can keep track not only of the incoming material, but we can keep track of the bales that are coming in as well. Take a walk around real quickly here. We can see we've got a mixture of chutes that are feeding immediately into balers as well as into bins. The bins are right here. Here are the balers. When we first put these balers in, we only put 2 in because we weren't sure how this was going to work out. Would it be better to use bins or balers? And the jury has come in, the verdict has been returned, and the balers are actually much better. And when you factor in that it takes 5 bins to feed a bale, the additional it's only an additional $10,000 to put a baler underneath of a chute. And when you do so, you reduce the amount of storage you need right away, you reduce the handling, and you end up with a much better return on investment than you would with the bins. Let's keep moving. Here we have material coming directly from the table into the baler. It's now a bale. It's going to be brought over to the scale, which is over back here behind me, and weighed. Now, future developments in terms of working with baler manufacturers will include scales in the balers so that we do not have to do the weighing step, but we'll also get some additional feedback because we'll have the ability for the scales in the balers to feed directly into Simple Insight. Now, why are we doing all this tracking? Well, I'll show you here in a sec here. We can track the amount of inventory we have here by tracking our incoming material, our outgoing material, and our production. And from Golden, Colorado, Lawson, Oklahoma, Colorado Springs, Colorado, all of the folks we ship to can monitor our inventory, and they can get trucks automatically without any real interference from us as we go. This storage area is about 3,000 square feet. That's by design. We don't want to have any more material in this area than is necessary because we want to turn this material into cash as quickly as possible. The longer it sits here, the longer it waits for the truck to come, the more cost we're incurring by storing it, and the more cost we're incurring just by holding the material. So we want to turn it into cash as quickly as possible and keep moving. Here the truck has come. We're loading some mixed metals into the truck. And the truck, that's one of the advantages of having the truck near the source, is that this truck would have left town empty to head to Denver. Instead, it's gonna pick up a load here and head on its way directly. So not only have we recycled a bunch of material, we've also managed to recycle a truck. I'm going to go ahead and report our sold material to our system. That way we can go ahead and invoice the customer as necessary. One other thing we can do is we can also track hours through the system as well, so that we can track our efficiency as well as run payroll. And here we have where we successful today. We can track our inventory, we can track our production, incoming material, and so on, and make sure we provide a good balance of things, as well as track our machine utilization. One last thing before we leave, I want to call your attention to the roof of this facility, which has solar panels on it, covering about half of the roof. Those solar panels will power during a day like today, more than enough power for the facility. I actually will net meter back, but in the wintertime, it will go ahead and it will produce the material, or enough power, just about enough power to power the facility, but we'll get a little bit from from the neighboring power plant, which is down towards the airport. It's about 8 to 10 miles to the west. And you know, it's a coal-fired plant, so the more we can generate here on the roof, the better overall for the environment. Real quick, let's do a quick recap here. We talked about the trucks arriving. We talked a little bit about floor space and about the need to meter the material for accuracy. We talked about sorting and how we get better of our workers on the sort floor at the table. We talked about balers and about how you know, we could have 5 bins, or we could spend an extra $10,000 and have a baler, and how that works out better than using an Autotie baler that's, you know, fed by everything else. We talked about minimum bale storage to try to reduce our overall footprint and reduce the amount of time that material is waiting to be turned into cash as it goes, and talked about this idea of faster cash and higher productivity overall. At this point, we're getting pretty close to the end. I think we got about 5 or 10 minutes before Amy kicks us out. I'm open to questions. You can raise your hand, and Amy or Kevin will voice for you, or if you can unmute, go right ahead and fire away.
We also have a couple questions in chat.
Perfect. Hit me.
Okay, this one's from Vanessa. What happens to all the material that falls off and that's covered on the floor after sorting in the bins?
Material that's on the floor after sorting, that gets swept up and it's pushed back into the tip floor area where it can get sorted again. We only have that problem where we have these bins, and like I said, if we're going to build this again, we'd probably put balers in a couple more places to reduce the bins.
Great. And Susan wants to know, in what ways do you continue to reconfigure your facility to meet needs?
Well, when we first started in 2016, this facility did not have a compactor, which we didn't see, which is on the outside of the building. It did not have a waste conveyor. It had a lot more bins and a lot more movement. Subsequent to that, we've added a waste conveyor. This summer, we're going to try to add a couple more balers. We're going to add one more horizontal over here for the mixed paper, and we're going to add a test baler. We get balers in some cases from manufacturers so that we can test them here. We're adding a test baler back over this way. We're probably going to work that one. It's a little easier to move. It's vertical. We're going to put that on a couple other stations, and that baler is going to have it's going to have the scale in it. So lots of different ways to reconfigure the machine, not just for us as tests, but for the community as the program grows. This facility right now in 2020 is processing about 2.5 times the amount of material that it was processing in 2016. Upgrades, additions of balers, and things like I've just lined out will enable us to more efficiently take on even more volume to where we can get to. We should be able to get to about 4x what our volume was in 2016, just on this one system with a few modifications.
Fabulous.
One thing I would note is that this system, because of the way we've configured the deck, the flexibility for people allows us to scale up and scale down our labor, which is one way of adding capacity. But then as we remove work through addition of automation, we'll also be adding a new and improved magnet that's going to include an integrated eddy current into it. As we start to do that, we'll get even more capacity out of the machine beyond just adding people.
Vanessa has another question. Do you keep track of what happens to material once it's shipped off on the trucks?
We don't trace it. We take our customer's word for it that it's being turned into a new can or bottle or piece of plastic or cardboard. We ship direct to Lawton, Oklahoma, where there is a plant. We also ship direct to a customer in Colorado Springs who's turning the material into an insulation. So we know, in terms of traceability, where that's going. The plastics, we know it's tending to West Coast processors, and then all the metals end up going to Denver for Reclametal or one of the local scrap yards, where it's then turned into its next iteration in life.
Great.
So we don't trace it all the way to the box, but we do trace it to the mill.
Okay. I think we have time for one more question if anyone wants to chat that or unmute yourself and ask it live.
One thing that we are careful about is traceability on the front end, because the traceability on the front end improves your chances of traceability on the back end. Having a facility in Steamboat Springs allows us to track back to the truck, and in some cases back to the actual consumer, when we have issues of contamination and things like that. We have the ability to measure our residue rates and provide feedback to the community, but we can also inspect trucks as they arrive so that they don't get lost in the big MRF. We are able to track them as they arrive, provide feedback to the drivers, as well as provide feedback to the drivers' companies in an effort to try to drive our residue rate down. We do try with some limited success. We're really busy. We do try to provide feedback to the local radio station and others, the Yampa Valley Sustainability Council, when we have unusual contaminants, to try to make sure that we've got the cleanest material around.
Thanks, Pat.
Was that the buzzer?
Yeah, I see the bus outside.
Okay. Well, thanks for coming. Thanks for visiting. If anyone would like to repeat the tour, feel free to reach out to me, Sagar Bhatt, who's our production guru here, or Kevin Andreessen in business development. We'll be happy to arrange a tour for you and your group. Thank you.
Yep, or check back later at 12:30 today while you're given another tour virtually.
Amen.
Thanks, Danny.
Yep.
Okay, thanks all. Thanks for attending.
Stay.